Okay, this is the second video for 8.2 notes. We just calculated the test statistic of 1.60, and our question is that far enough away? So back to our notes. So we found the test statistic, and then we'll have to figure out the p-value. I'm going to move forward a little bit here. To figure out my p-value, I have to know what type of test I'm doing, since the sign used in my alternative hypothesis, which is over here, since the sign used was a greater than, this is a right tail test. Okay, so that is important. This is a right tail test. And actually you have a little flow chart, and this is also printed on your green packet. So procedure for finding p-values, which again is on your printout. What type of test is this? We just decided this was a right tail test. So therefore the p-value is the area to the right of the test statistic. Okay, so basically now I go back to stuff I've been doing for over a month, and I figure out the area, to the right of the test statistic. So on your z-score sheet, we found the test statistic to be 1.60. I just want the area to the right of that. So remember, your z-score sheet will give you the area left. You'll have to do 1 minus that, which will give you a p-value. Now, by the way, this is capital P of 0.0548. I'm going to do step 7's p-value method, and then I will jump back up to the critical value method for steps 6 and 7. Basically, these are two different ways to get to the same answer. So on step 7, p-value method, make a decision to reject or fail to reject. Looking at my notes, so the p-value method, if the p is less than or equal to alpha, we reject. If it's greater than alpha, we fail to reject. A phrase you'll hear me use on these videos is, if p is low, p is low, null must go. So if the p is lower than significance level, the null must go. Well, my p-value was 0.0548. My significance level was 0.05, so the p was not lower, it was bigger. So since p is bigger than alpha, this is a fail to reject. So a little bit about the theory behind what we just figured out. Essentially, what we figured out was that finding 58% girls had about a 5.48% chance of happening. So if it was true that only 50% would have been girls, getting a result of 58% had about a 5.48% chance of happening. Now, while that's pretty low, I set my benchmark where basically only things are weird if they happen less than 5% of the time. This goes back to some stuff we've said since the beginning of the semester. So my cutoff for weird stuff was 5%. This was something that could happen a little more than 5%. So it's not enough to say it's weird, which means I cannot reject. So I fail to reject. So that's using the p-value method. Another way to get to the exact same conclusion is to use the critical value method. Let me find the right thing here. Okay, there we go. So the critical value is basically the region. Excuse me, the critical value is the number that cuts off the region that has the significance level alpha. So what the heck am I talking about? The other way to look at this, after I got the test statistic, so again, remember I got the test stat of 1.6. And again, I want to know, is that really weird? Is that really off in the tail? Well, an alpha of 0.05 well, that corresponds to an area in the tail. So there's 0.05 in that tail. I can find, using my green sheet, the z-score that goes with that. Again, it's this cutoff line. The z-score that goes with 0.05 to the right is 1.645, which again is on your z-sheet. This is the critical value. So again, this is just another way to try to arrive at the same conclusion. I'm showing you both ways because we're going to use p-value a lot, but then later on we're going to switch over to critical value, so we need to know them both. Anything that is in this region beyond the critical value is considered weird, hence all the weird colors. Well, my test statistic of 1.6 would be just a little bit short, not by much, but it would be here. So it's not in the critical region, so it's not weird. It's real close, but it's not weird. Which, looking back at our notes, again, 0.58 is just short of that critical region. That's where I would say things are weird. Which again, if I look at step 7, if the test statistic falls within the critical region, we reject. If it does not fall in the critical region, we fail to reject, which is the same conclusion we got. Fail to reject. So either way, we ended up with fail to reject the null. Step 8. Now on step 8, it says simple and non-technical terms. They're not necessarily simple and non-technical, but we're going to follow a different flow chart here, which this is also printed in your green packet, and we're going to be using this chart several times. Now we finally state our conclusion. So for this problem, did the original claim contain the condition of equality all the way back up to the top? The original claim was P is bigger than 0.5. There's no equal to in that. So no, it did not. Do I reject the null? No, I did not. I failed to reject. So this is how I word my result. And I have this again printed on the answer key to the worksheet, so I'm not going to rewrite the whole thing, but I would basically say there's not sufficient sample evidence to support the claim that the proportion of girls is greater than 0.5. So essentially, here's what we figured out. We cannot support that this XORT method actually makes girls more likely. We can't deny it, but we cannot support it. 58% was real close, but it wasn't quite enough. Yeah, it was more than half, but it wasn't enough. So really, in the end, after all of this, we basically throw our hands in the air and say, I don't know. Sorry, can't help you. Notice that, and let me make this full size here real quick, that in half of our possible conclusions, we actually don't really arrive at anything. There's only a 1 in 4 chance that will reject the original claim. There's only a 1 in 4 chance that will support the original claim. The other 2 times, here and here, we basically say, we don't have enough info, sorry, the data doesn't help. So I'll stop this video there, and then we'll do the back of this worksheet on the last video.